So here we are with series, which are sums of sequences. So we're going to take the sequence and sum it up. And we have three formulas that we're going to refer to. This is arithmetic sequence. This is the geometric sequence that stops. And this is geometric sequence that never stops, ever. So let's go ahead and give this a try. So we take 5 plus 8 plus 11. This is adding 3, adding 3, adding 3. Hey, look at that. That's pretty nice. So we're going to take this plus that. That's 91. That's your A1 plus AN. And then we've got to find out how many pairs we have. So 8 in the next one and 11 in the next one. They all make 91s here, but how many? Ooh, how many is it? So we know we've got from 5 up to 86 is a distance of 81. And we know that we take steps of 3 each time. So that means if we had 3 and 3 and 3 and 3, 81 divided by 3, punch that into the calculator, and we get 27. So there are 27 steps starting from the number 5, which means there were 28 pieces divided by 2. So there's the n is 28. There are 28 terms. We divide it by 2, and that's how many pairs we get that add up to 91. So we get 14 times 91, punch that in the calculator, and we end up with 1,274. Excellent. Number 2, let's try this. So here from 4, wow, up all the way to 59. And it's 4, 9, 14. Can you see that we're adding 5 each time? So this is, again, the arithmetic sequence. And so the sum is going to be, let's see, 4 plus 159 is 163. And 9 plus the next guy, 154, is 163. And so we're going to have 163 times, oh boy, n over 2. How many terms do we have? Well, from 4 up to 159 is 155. We take 155 divided by 5 in our calculator, and that means we have 31 steps. 31 steps, that means 31 additional terms plus the third, that we have 32 steps. 32 terms in here. That means there are 32 divided by 2 is 16 pairs of 163. It's 2,608. Excellent. Okay, number 3. Ooh, this one starts at the number 1. So it goes 1 plus the number 2 is 4 squared, plus 3 squared is 9, plus 4 squared is 16, plus 5 squared is, oh boy, that's 25, plus 36, plus 49, plus 64. And it stops right there. Now, that distance is 3, that distance is 5, that distance is 7. Ooh, there's not a pattern. We can't use those formulas up there as far as summing it up really quick. So we just have to add them up. And so if we add them up, we get, that's 10 and 20, so that's 30, and 55 up to here is 55, plus 100. So 155 plus 49 is 204. That's what we get there. Good. Okay, so let's try this one. Ooh, hope this one has a pattern. If we stick 1 in, we get 7 minus 4 times 1. That's number 3. Stick 2 in here, and we get 7 minus 8 is a negative 1. All right, 3 minus 1. Then we stick a 3 in there, and 7 minus 12 is a negative 5. Ooh, 3 minus 1 minus 5. The next one, ooh, we're minusing 4 each time. Let's see if it really works. Stick in a 4, and it's 7 minus 4 times 4 is 16. 7 minus 16 is a negative 9. Yep, this is an arithmetic sequence, and that is the common difference each time. And we're going to go clear down to sticking in 26. So 7 minus 4 times 26 in a calculator gives us a negative 97. Woo! So the one before that was a negative 93. Oh, and we're adding all these guys up. So here's the formula right here again. So we're going to take the sum is the number of terms. Oh, this is easy. We know there are 26 terms. So 26 divided by 2 times the first plus the last. So we get 13 times negative 94, which equals negative 1,222. There we go. Okay, this next one. Ooh, we're starting at 4, not at 1. That's kind of interesting. So stick in 4, and we get 3 times 4 is 12, minus 5 is 7. And then stick in 5. 3 times 5 is 15, minus 5 is 10. And stick in 5. 6. 3 times 6 is, ooh, what's 3 times 18 minus 5 is 13. Now you notice this is an arithmetic sequence, and we could do it that way, or we could just add it up and get 30. And that's it. So number 5, the answer is 30. Now we could notice that we could use this formula. Let me use a different color so we can see that if you took, there are 3 terms times the first plus the last. And that's what that formula says. The number of terms divided by 2, first plus the last. 7 plus 13 is 20 times 3 halves. Oh my goodness, look, it comes out exactly right. These formulas really do work. Okay, number 6. The first term, 3 plus 2 is 5. And then you would take and add that, stick in 2, and you get 3 plus 4 is 7, and plus and so on. Notice again, that's the common difference, whatever you're timesing by here. And it has 82 of them, from 1 all the way up to 82. Stick in 82 in for n to find the last term. 2 times 82 is 164. 167. Holy cow. So the summation is going to be the number of terms. There are 82 here because it started at 1, went up to 82. So there are 82 divided by 2 times the first one plus the last one. And we get 5 plus 167 is 172 times 41. That's 82 divided by 2. And we get 7,052. Woo! Look at that. Okay, number 7. Oh, there's a different type of one going on here. It starts with I equals 3, so 5 times 2 to the third power. So 5 times 8, that's our first term. So let's write it down here. We got 40. The next one is 5 times 2 to the fourth. 2 to the fourth is 16 times 5. Punch that in, we get 80. And then we times by the next one, 3, 4. We're going to put 5 in for I. 2 times 5, no, 2 to the fifth power is 32. Times 5 is 160. And you notice what kind of sequence is being created, where we're timesing by 2, timesing by 2. And that's exactly what happens. Every time we put another number in here, the end result will be 2 times larger. So we have, if you put in a 6 right there, we're going to get 320. And then add all that up, and you get 200 plus 400, you get like 600. All right, 40 plus 80 plus 160 plus 320 should give you about 600. Now you'll notice this is a geometric sequence, and we can use this formula right up here if we would like to use that. Our first term is 40. So if you take 40 times the common ratio, which is 2, to the 1, 2, 3, there are 4 terms, so fourth power minus 1 over common ratio minus 1. Interesting, here's the common ratio. You should note that here we're going to have a common ratio of 4, a common ratio of 2, a common ratio of 2, and that'll help us later on. So 40 times 2 to the fourth is 16, minus 1 is 15. 40 times 15, and oh my word, the formula works. This one's small enough we could do it by just rote stuff. This guy, there are going to be 9 terms. So let's figure out the first term, first of all. The first term in this one is 5 times 4 to the first. So the first term is 20. And yeah, each one after that, we're going to have a plus 80, plus a 320. We're going to keep going on and on. 9 terms, which is huge. 4 to the 9th times 5, I don't know, something very big. Let's punch that in. 4 to the 9th times 5 is like, oh yeah, 131 or 1,310,720. Woo! It's a big number. And we're going to add all those guys up. I'm not going to do that. I'm going to use this formula up here. So the sum is going to be the first term, 20, times 4 to the 9th power, there are 9 terms, minus 1 over 4 minus 1. So 4 to the 9th minus 1. And then I'm going to divide that by 3. And I get 87,381. And now times by that 20. And it all equals 1747,620. Whew, big number. Okay, the next one, we'll just jump straight and use that formula right from the get-go. So the sum is the first term, which is 3 times 2 to the first, which is 6. Common ratio is 2. We're going to have 12 of them, so that's our k, minus 1 over 2 minus 1. So the common ratio is 2 in this case. And we get 2 to the 12th, I don't know how big that is, minus 1 is 6 times 4,095 over 1. So times that guy by 6, and we're up to 24,570. It's important to remember how you put these things in here to make them work. Number 10, we get, we're starting from 6 to 15. That's tricky a little bit. So our first term is going to be 7 times 2 to the 6th. Now 2 to the 6th power is 64, so 7 times 64 ends up being 448. Common ratio of 2 because it times by 2 every time n gets 1 higher. But notice we don't have 15 terms. Our k up here, that's the number of terms. And so that one, yeah, we've got to look at that. 6, 7, 8, 9, all the way up to 15. There are 10 terms. Now, some of you may think, oh, 15 minus 6 is 9. That's correct. It is, but you forget you start with 6, so we actually include 6, and then all the way up to 15. So there's the first term, which is the 6, and you can count it out on your finger. 6, 7, 8, 9, 10, all the way up to 15. You'll have 10 of them. Minus 1 over 2 minus 1. So 2 to the 10th minus 1 is, punch that in, I get 1,023 divided by 1 times 448. And we get a big number. Turns out to be 458,304. But yeah, we just added all those guys up. Now this is interesting. You'll notice this term has an infinite amount going on here. That is where this term comes in really, really handy, right there. So the sum on this one is going to be a times, so 7 times, what's 1/2 to the 0 power? 1/2 to the 0 power is just 1. So it's going to be 7 times 1 over 1 minus r, which is 1/2. Common ratio is 1/2, so we get 7 over 1/2, which equals 14. Now this division by fractions, you flip and multiply by that reciprocal. Okay, so right here, again, k equals 0. Anything to the 0 power is 1. So the first term is 5 times 1 over 1 minus 2/3. That's 5 over 1/3 equals 15. So this adds up to 15. All right, the next one. This is tricky. They start with 2. So 2 goes up here. And so you get 3 times 1/5 squared. That's the very first term, is 3/25. So that has to be times by 1 over 1 minus 1/5. This is a common ratio. So we get 3/25 times 1 over 4/5, which is the same thing as 3/25 times 5/4. The 5's cancel. 3/5 times 1/4 gives us 3/20. It's kind of fascinating little guy right there. Okay, next one, 14, has a very similar thing. It's getting kind of crowded. Let's use a different color. The first term is 2 times 3/4 squared. So 2 times 3/4 squared is the first term. And then we're going to times it by 1 over 1 minus 3/4. So 2 times 3/4 squared is, let me see, that's 2 times 9/16. So it's going to be 9/8 times 1 over 1/4. So 1 over 1/4, flip and multiply, and you get 4 over 1 equals 9 halves. So about 4.5, or exactly 4.5. Okay, that should do it.